Hello, Physics Nation. My name is Nate Larmond, and I'd like to do a Khan Academy problem, this time with a handwritten solution. So the problem asks to find the acceleration of this block coming down the ramp. And the whole key to these problems is to tilt your frame of reference. Let's see, to match the inclined plane. The new frame of reference is parallel is described as x, and perpendicular is described as y. And really the whole trick is to split the weight into two components, one that is into the hill or perpendicular hill, and the other that is parallel to the hill. And as you can see, adjacent to this angle is the perpendicular component, and opposite to this angle is the parallel component. So in order to find the portion of the weight that is into or perpendicular to the surface, we just use cosine. Cosine of theta describes the ratio of the adjacent leg to the hypotenuse, so how big this guy is compared to this guy. And if you want the adjacent, all you do is multiply both sides by mg. So, pardon my scrolling, if you do mg cosine of theta, that is the perpendicular component of the weight. Except in this problem, we don't want the perpendicular component of the weight, we want the parallel component of the weight. So in this case, you want the opposite leg, this guy right here, fg sub x, or the parallel portion of the weight. So again, we start with a basic trig function, sine of theta equals opposite over hypotenuse. Substitute in the physics values of all these things. The fg sub x is the parallel portion of the force due to gravity. And again, we just multiply both sides by mg, and you get mg sine of theta equals the parallel portion of the weight, or fg sub x. And sorry, it's kind of small here. All you do is use f equals ma. So mg sine of theta is the opposite leg, and there's a upwards push, which is negative in this frame of reference. So in order to find the acceleration, you just divide both sides by mg, cancels out in this term, and you get g sine of theta subtract f divided by m equals the acceleration. Thanks for watching. See you in the next video.